Good morning, students. Jai Swaminarayan. In the last lecture, we took exercise 7.3, sum number. In the last lecture, students, we took exercise 7.3, sum number 11, where the letters of the word permutation, where the letters of the word permutations are arranged according to the given conditions. I told you, students, the first two parts we have already done. The third part is simply superb, which we have to understand. And the condition is there are always four letters between P and S. Now, total letters are N is equal to 12. That's what all of you would have understood. Now, if I draw 12 boxes, the part is 4 letters between P and S. So, if I draw 12 boxes, which is quite obvious, here P and here S. Second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th and 12th. Okay, sorry. I should take S as the last. But as per the spelling, okay. Now, between P and S, we should have 4 letters like this. Students, the condition of the sum is to be very carefully and very perfectly understood. There should be always 4 letters between P and S. So, positions for P and S. First, second, third, fourth, fifth and sixth. So, first and sixth. Now, it is not that these are the only positions. I shift one, then it will be second and seventh. Again, if I shift one, then third and eighth. Again, I shift one, then fourth and ninth. Again, I shift one, then fifth and 10th, again I shift 1, 6th and 11th, and last 7th and 12th. So these are the positions, students, which can be occupied by P and S. Check, I shift 1, I take one right here. Again I shift 1 like that. So these are, students, the possibilities for positions of P and S. Now, mind you, S can come first and P can. The arrangements can be like this: P, S or S, P. Between P and S, it is not told that P should be first. So, the total positional arrangements are the total positional arrangements are 7 into 2, 14. The same position can be flip-flop. First P and then S, or first S and then P. Now, the remaining 10 letters can be arranged in 10 factorial divided by 2 factorial. Why? Check. In E R N U T A T I O N. In these 10 letters, T is repeated twice. Therefore, total words with given condition is equal to 14 into 10 factorial upon 2, 2 ones are 2 sevens are. This is a very large figure which comes in lakhs. It is 25 lakhs 47. It is in crores. 2 lakh 54 lakh 1600. 2 crore 54 lakh 1600. Unit 10, 100,000, 10,000 lakh, 10 crore. So this may be students. It is simple multiplication which I have to calculate students beforehand. So the best part of the sum is to understand the relative positions of P and S and their flip-flop. 7 positions final, but it can be first P and then S, or first S and then P. So the total positions will be 7 into 2. And that is how many students 14. For the remaining 10 letters, out of this 10 letters, T is repeated twice. So the remaining 10 letters can be arranged in 10 factorial divided by 2 factorial. So this completes our exercise 7.3 students. Now, another fascinating concept of the chapter P and C. In short, we call this as P and C. The second half of the fascinating concept is combination, students. And trust me, this is one of the most ever interesting concepts studied in practice. Combination. This is one of the most fascinating concepts, as well as interesting concept. Now, what is combination, students? How to define combination? Now, let us understand this with an example. Say, festival season is over, but winter season is already on. And you go to buy a pair of shoes, isn't it? Imagine a very, you can say, hi-fi mall, say Alpha Mall in Ahmedabad, isn't it? Don't go there. This is just an example. Say you go to buy a pair of shoes and you have 4 options. The first is always RBK, Reebok, then Nike, then Adidas. And then says Skechers. These are my favorite companies for buying a pair of shoes. I always choose my pair of shoes from these 4 companies as far as sports shoes are concerned. So total available companies are 4. So students, we write N is equal to 4. Total available companies are 4, and total always in P and C, students, is indicated by, you can say, N. Now, students, you at this level will definitely go to mall with your parents, and when your mother is accompanying you, she will tell that only 2, not all 4. You have to buy only 2 pair of shoes. Till day my mother also tells at this age. So I am definitely sure that at your age the mother will be restricting you. Only 2 pair of shoes. That too, she will tell with, you can say, with harsh heart, otherwise only 1, but 2. So number of pairs which you are going to buy are denoted by R is equal to Now definitely when you go to buy a pair of shoes, you will try it, isn't it? So what are the possible selections you will have? Say Reebok and Nike, Reebok and Adidas, Reebok and Skechers. Now Reebok or Nike and Reebok is the same selection. So next pair will be Nike and Adidas, then Nike and Skechers, and then Adidas and Skechers. These are the only 6 possibilities for buying 2 different pairs of shoes. Nike and Reebok or Reebok and Nike is same. First you buy Reebok shoes and then you buy Nike shoes, or first you buy Nike shoes and then Reebok. Finally you are going to take those 2 pairs of shoes at home. So order in which you select is not important in combination. The order in which you select the item, students, is not important in combination. So what is the definition of combination? You will have 6 options here. As per what you can say general view, we have 6 options. So 6 options, or you have 6 selections, or you can have 6 different ways in which you can select a pair of shoes. So what is the formal definition of combination? The total selections of R things in any order out of given n things are called combinations of R things. I repeat. The total selections of R things out of given n things are called, students, combination of R things, and it is denoted by NCR. N stands for total given things, R stands for selected things, and of course C is combination. Recall the definition of permutation. What was the definition of permutation? The total arrangements of R things out of given n things are called permutations of R things, and it was denoted as NPR. N stands for total things, P stands for permutation, R stands for arranged items, objects or things. In combination, R stands for selected items, objects or things. And in combination, the order in which, students, you select the items, in combination, students, the order in which you select the items is not important. The formula for combination is NCR is equal to n factorial upon R factorial into n minus R factorial. This is extra in combination. Why? Because the order of selection is not important, so you can write it as NPR upon R factorial. So NCR into R factorial will give us NPR. So this is very, very important, students. The formula of NPR we know. So let us revise. It is n factorial upon n minus R factorial. So in permutation, order of things is important. Order in which you arrange the items is important. 2, 4 is the number 24. But if we interchange the digits, the number changes to 42. But here, Reebok and Nike and Reebok means the same selection. So in permutation, order in which the items are arranged is very important. In combination, the order in which you select the items is not important. Word order important for permutation. Word order not important for combination. That is why the definition of combination goes like this: the total random selections of R things. When I use the word random selection, it means you can select the things in any order. The total random selections of R things out of n things is called combination of R things, denoted by NCR. Now, if I go with this example and if I apply the formula, total I have 4 copies of shoes and selecting A2. So if I simplify 4C2 according to this formula, it will be 4 factorial minus 2. 4 minus 2 is 2 factorial. This is 24 divided by 4. I get 6. Same 6 options I will here. Check. So, if I go by definition with the example, given 4 companies of shoes, out of which any 2 companies of shoes can be selected in 4C2 ways, and that is called combinations of 2 pairs of shoes, which are 6. So, the total selections of 2 pairs of shoes out of given 4 pairs of shoes is done in 4C2 ways, and that is called combinations of 2 pairs of shoes. That answer according to the formula is 6. So, out of 4 pairs of shoes, I can select any 2 pairs of shoes in 6 different ways. So, students, remember this: permutation and combination are same side of a coin. In permutation, the order of arrangement is very important, and in combination, the order in which you select items is not at all important. This students, we have to perfectly memorize and remember. Now, students, few basic derivations, important results. We should say certain important results which we have to memorize. Students, the first and the foremost result is the standard formula of combination. NCR is equal to n factorial upon r factorial into n minus r factorial. If I divide the permutation formula by r factorial, students, I get the formula of combination. Second, on simple cross multiplication, you know this: NCR into r factorial gives NPR. NCR into r factorial, students, give us NPR. Third, students, third formula: MC0 is 1 and MCN is also 1. Students, pay attention. Say, given are 4 pair of shoes, out of which you are selecting any 4. Given 4 pairs of shoes and you are selecting all 4, it can be done in only one. That, say, you are given Skechers, Adidas, Nike and Reebok. You buy a pair of shoes of each company, then that can be done in only one way. You take all these 4 pairs of shoes in the bag and go home. Given 4 pairs of shoes and you reject all, that can be also done in only one way, that you don't buy any pair of shoes. So NC0 is also 1 and NCN is also 1. 4C0 is also 1. Out of 4 shoes you reject all. It can be done in only one way. And all 4 shoes and you buy all 4, that can be also done in one way. So 5C0 is 1. 5C5 is also 1. 8C0 is 1 and 8C8 is also 1. Then students, NC1 is n. Given 4 pairs of shoes and you buy any one, it can be done in 4C1, that is 4 ways. Given 8 pairs of shoes and you buy any one, it can be done in 8C1, that is 8 ways. So NC1 is always n. 8C1 is 1, 8C1 is 8, 10C1 is 10, 100C1 is 100, 49C1 is 49. In general, NC1 is n. Given n distinct things out of which you have to select only one thing, then one thing out of n things can be selected in, you can say NC1 is equal to n ways. Then students, the most important property of combination, NCX is equal to NCY. If 2 combinations with same n are similar, then their R are similar, or addition of both the R will give us n. This is actually R. So if NCX is equal to NCY, if 2 combinations with same n are similar, then definitely their R's are similar, or addition of both the R will give us n. This is one of the most important property of combination which is frequently used in sums. Now students, the last property NCR plus NCR minus is equal to n plus 1 CR. This we will take with the help of an example. I will demonstrate this property students with the help of an example so that you can understand. The last property. Students, the last property I will explain with the help of a practical example that will make the concept more clear. Now students, NCR plus NCR means, suppose I write 7C3. So N is 7, R is 3. R minus 1 will be 2. So 7C2 will be equal to N plus 1, 8C3. R is 3. This is what the property tells. Let us simplify the left hand side. So the left hand side is 7C3 plus 7C2. So 7 factorial upon 3 factorial, 7 minus 3, 4 factorial. And this will be 7 factorial upon 2 factorial, 7 minus 2, 5 factorial. Reduce 7 up to 4. So 7, 6, 5, 4. 3 factorial is 6. 4 factorial 6, 6 cancels. So this is 35. Reduce 7 into 5 and get it cancelled. These are 2, so this is 21. So the answer is 56. Now, I simplify RHS, which is 8C3. So 8 factorial upon 3 factorial into 5. Reduce 8 up to 5 and get it cancelled. 6 is cancelled, 7 are 56. So you check LHS and RHS are equal. So this is a practical example demonstrating the property number 6. Students, check. This is a practical example, students, demonstrating property 6 and property 5. I will again explain when I take a sum based on that particular property. So this 6 results, students, we have to perfectly remember and memorize. This 6 results, students, we have to perfectly remember and memorize, and we will apply this results in doing the basic sums. Okay students, now let us start exercise 7.4. Let us start students exercise 7.4. The first sum. In that way we are going to apply this property number 5. If NC8 is equal to NC2, then find the value of NC2. Okay students. NC8 is equal to NC2. Sum number 1, NC8 is equal to NC2. Then find the value of NC2, students. This is what the question is. Now students, whenever you seem to practice the sums in permutation and combination, you should be very well aware of all the 6 results. So I am going to apply property of 5. If 2 combinations are equal with same n, so this is our x this is our y. So according to this property, I will have x is equal to y, or n is equal to addition of x and y, which is 10. Now 8 is equal to 2 is not possible. So out of this two, any one option or both the options are possible. Here, the first option x is equal to y is not possible. So n is equal to x plus y. Check students, here I have a Purani property number 5. So if NCX is equal to NCY, then students, either we have x is equal to y or n is equal to x plus y. So n is equal to 10. Therefore, MC2 is equal to 10C2, which is 10 factorial upon 2 factorial into 10 minus 2 8 factorial. Apply the standard formula. Reduce 10 into 8. 2 factorial is 1 into 2. 2 ones are 2. 5 is 9. 5 is 45. 45 students is our answer. So, this is very important students in combination and permutation to simplify perfectly. Now, second, first part, 2nc3 is to nc2 is equal to 12 is to 1. Again, find n. I am doing only the first part of second sum. Students, 2nc3 is to nc2. Answer to part first. 2nc3 is to use upon nc2 is equal to 12 is to 1. Then students, we have to find n. Okay. So in the first step, we have to apply the formula of NCR, but instead of n, I have 2n. So wherever there is n, we will write 2n. No problem. 2n factorial upon r factorial is 3 and 2n minus 3 factorial. Upon n factorial, r is 2, n minus 2 factorial is equal to 12 is to 1. So observe this step. It is directly based on the formula of NCR, which is n factorial upon r factorial into students n minus r factorial. N factorial upon r factorial into n minus r factorial. But instead of n in the numerator, we have 2n. Now that doesn't make any difference, students. Concept and formula remains the same. Now reduce 2n up to 2n minus 3 here. So from 2n, if I remove 1, I will get 2n minus 1. If I remove 1, then 2n minus 2, and then I will get 2n minus 3. 3 factorial is 6 into 2n minus 3 factorial. So this gets cancelled. Upon reduce n up to n minus 2 factorial upon 2 factorial is 2 into n minus 2 factorial. So this gets cancelled. This is nothing but 12 is to 1. So students, in this type of sums, our prime concern is to get factorial terms cancelled. What is our prime concern, students, in this type of sums? That we should have factorial terms cancelled. Now, n into n minus 1, this 2 I can shift in the numerator. So this step I am writing here. 2n minus 1. Taking 2 common, I will get n minus 1 divided by 6 into 2 upon n into n minus 1 is equal to 12 is to 1. From this, I can take 2 common and that is 2 into n minus 1. And this is 2n students. So 2 1s are 2 3s are n and n cancel, n minus 1, n minus 1 cancel. So what remains? 4 into 2n minus 1 divided by 3 is equal to 12 is to 1. So 4 1s are 4, 3s are. Therefore 2n minus 1 is equal to 9. So 2n is equal to 10. So n is equal to 5. This is our answer. So, in this type of sums, our prime concern is to get the factorial terms cancelled. So, let us revise the definition of permutation and combination at a time so that students you can understand what is permutation. The total arrangement of r things out of given n things are called permutations of r things denoted by NPR. The formula of NPR is n factorial divided by n minus r factorial. Then what is the definition of combination? The total random selections of r things out of given n things are called combinations of r things denoted by NCR. The formula for NCR is n factorial upon r factorial into n minus r factorial. What is important in permutation? Order. What is not important in combination? Order. The order in which you select items in combination is not important, whereas in permutation, the word order has lot of importance and significance. So if I say what is important in permutation, you should say order, and what is not important in combination, then also students you should say order. In combination, the order in which students the items are selected is not at all important. Then important result for combination NCR is equal to n factorial upon r factorial into n minus r factorial. Then NCR into r factorial is equal to NPR. NC0 is 1, NCn is also 1. NC1 is n. And last two properties very important. NCx is equal to NCy. Then x is equal to y or n is equal to x plus y. And last but not the least, NCR plus NCR minus 1 is equal to n plus 1CR. So this 6 results of combination you should again and again write to still you memorize. So here students we conclude our lecture. So in the next lecture we will discuss in detail the sums of combination. Thank you students.